myself more formally, and
Okay, there we go.
I'll introduce myself more formally in just a moment. But you know, Becca and I are here tonight to help you be successful. You're plenty smart enough. You're very good at learning, and you're going to have very good projects. And our job here is to help you be even more successful. And uh, I know it can be tough in a situation like this to ask questions and to speak up. I know I have trouble with that too. But I would love it if you ask questions or stop me, and we'll talk a little bit about that as we go along. But I'm going to do some PowerPoint slides. And again, please stop me at any time if something doesn't make sense or I'm not speaking to something that you need. I talk about a winning science fair project. I don't necessarily mean winning the prize, but one that wins for you, one that works for you. We're here in chemistry and in chemical engineering. I'm a chemical engineer, so a little different. So first of all, introductions and why we're all here, and I'll call on you a little bit. Again, you don't have to say anything, but I would like to know, sort of, why are you here? Why did you want to do something in this field as opposed to some other one? Uh, One big thing, and I know I was talking to Becca before this, is some of you are well on your way. You've got ideas, you've got plans. Some of you are still at the stage of working on coming up with ideas, and we'll talk more about that. But ideas for your project, uh, then something that you're better at than me is learning. And so learning about the chemistry for your project, learning about what you need to know to make this project work well, to understand what happened, be safe. You're very good at that, but we'll talk a little bit about that. Planning, which is a little different, and we'll talk more about that. Something that, again, I'm still active in this field. Today we're working on a new project, and that's exactly what we were doing. Just trying to plan how we're going to do this, and we'll talk a little bit about different ways to go about that. Then there's the actual physical setup of the experiment. So in chemistry, you usually wind up doing something, mixing something or observing something, something like that. So how do you set those experiments up? And I've spent my career doing this, and I've made my mistakes, but most of them have worked pretty well. In general, in chemistry and chemical engineering, learning is pretty easy, and you're able to get to good answers pretty quickly for the simple reason that the systems are fairly simple, as opposed to say social sciences or life sciences where things are more complex. Chemistry is pretty straightforward. Chemistry is always paired up with safety, and we'll talk about safety in chemistry. My main message to you there, and I'll say it at the end, with the right kind of training, you can handle any chemical. I can handle any chemical. My father made plutonium or hydrogen bombs, and he handled that. So safety is very important, but it doesn't keep you from doing things. It just slows you down.
Hmm.
Then the actual doing the experiments, and that's a big part of it. This is the fun part. Our business is about measurement, and I went to school, and one of my professors said, "You don't really know very much in this business, so measure everything you can, calculate everything you can." So it's a skill in itself, measuring things, and how do you go about measuring something? Talk about that a little bit. Part of the science fair program is the notebook and the reports that you do. I'm a judge for science fairs, and that's one of the things we look at. The poster and the displays, these are a lot of fun, and I've seen some wonderful ones, and I hope you have fun with this. And then your presentation, hopefully you're in a team, and there's something I just love, and I'll say it again, is when several members of the team pop up like one after another and each speak to their part. But an individual is also very good. And we'll talk about, what the judges are looking for. I've judged science fairs for 8 or 10 years, long time. And what we're looking for in a good poster. One thing I want to tell you about us being judges, though, is that a friend of mine, we were both judges at one a few years ago. And he walked by me, he said, "These people are us." And what he meant by it is that at your age, you are already techies and you have more in common with me than you might think. And yeah, sure, you're younger and you have some education to do, but fundamentally, you already think like a techie. And that's your card here, right? When you're dealing with the judges, you're dealing with someone that's really a member of the same group as you are. So it's going to be fun that way because they're going to like the same kind of things you do. I know I certainly do. That We're techies. We really like talking to each other, and we'll talk a little bit. So, are any questions about that part so far? What we're going to cover, this sort of the outline. And certainly, Becca, if you've got any comments, I appreciate that too.
They're great.
So here's John. Um, I'm a chemical engineer. There's a picture of me in a chemical plant. I'm age 69, married with two adult sons. They both live in Colorado. We live on a small horse farm in northeastern Massachusetts, a town called Dunstable. And by small horse, I mean small horse. So there's my wife with one of our small horses. This is Bucky. Both of these two horses are trained to go into nursing homes, and they deal with sick people, cancer patients and things like that. So these things go inside. He's got little shoes that he wears. They're absolutely adorable. So I'm a chemical engineer. I started out life as a chemist, and my dad suggested that I go into engineering. I'll talk a little more about that. I got my BS in chemical engineering from Louisiana State, and way back in 1977, and PhD in chemical engineering from Purdue. I studied catalysts. These are things that facilitate chemical reactions. At the time, gasoline was very short supply, and so we were looking to make our own gasoline from coal. Uh, so a PhD is something that certainly not necessary. If you want to work in research, they're good, but a bachelor's degree in any of these fields is perfectly okay. Uh, PhD doesn't cost anything. They pay for your training and everything. It's no problem. So I've been in industry. I taught MIT one semester, but for the most part, I've been in industry, what they call chemical process development. And what that means is there's something they want to make. My job is to figure out how to make it safely on a real big scale, cheaply enough to make money. So a lot of the things that are in your life right now, things that you're touching or near you, are things that I've worked on: plastics, metals, drugs, small molecules of various kinds. My principle is I'll never work on poisons and I'll never work on weapons. My father worked on weapons, my brother worked on poisons. So I try to only work on things that are okay. Now, people might say plastics, but plastics are an enormous amount of fun. So again, I'm an engineer. Dad and my brother and my mom's dad are all chemists. Um, I work today in new metals process. So metals is not something I've worked with much before. But you see this in the news right now, all this talk about rare earths and the China cutting off rare earths and this kind of stuff. This is an effort to secure a domestic supply. This particular one, neodymium, goes into the magnets that are in electric cars and e-bikes. So it's in short supply. And we're working on a new route to make this. We make it with sodium metal. Other people use electrolysis. We'll talk about that. So I'm right in the middle of it. And one big one is the difference between an engineer and a chemist, an engineer and a scientist. Chemists are scientists. The way I like to look at it is the scientist creates knowledge. They use other knowledge to do that, but as a foundation, but their work product is knowledge. Whereas an engineer uses knowledge to do things, to accomplish things. Now, this is a little bit of a fuzzy definition, of course. A lot of my brother's a pretty good engineer in some ways, and I've had to do science, of course, in order to figure out what I need to know to make my thing work. But that's a question you might ask yourself for your career is, do you like finding things? Do you like discovering things? Or do you like making things work, making things happen? And my dad was very much a discovery guy, and I'm very much of a make it happen guy. And we loved each other, knew each other very well, but there's different ways. That's one of the beauties of this area is you can be either an engineer or a scientist, depending on what you want to do. So that's me. Now, drum roll. It's where I hope you'll say something. So, what brings you here this evening? And maybe do you have a favorite area of science? And when you looked at that thing I put up before, is there anything you'd like to cover? So, yeah, again, I don't want to put you on the spot. If you don't want to speak, that's of course fine. But any of you, how come you're here? Why did you spend this time with me instead of someplace else? Any thoughts?
There's a couple folks that want to speak up. That's great. And then other people
Yeah,
can talk
Lily
some
raised her hand.
answers.
You have to
Yeah.
unmute yourself.
Mhm.
Thank you.
Hello. Yeah, so my name's Lily. The reason why I signed up for this webinar is because I really like chemistry. Chemistry is the way that is my favorite natural science, and the fact that I every day molecules and particles are made out of things that I can then like study and look at the bonds, look at like how chemical reactions happen. So chemistry is my favorite area of science. Um,
Easy.
yeah, so I guess I just came to kind of learn about how to integrate chemistry into like science fair because I've always done botany related science fair projects because it seems more accessible. Like I don't have a lab at my house, so I guess I just kind of want to know, hey, like I really like this thing. How do I incorporate it into something that I can actually do?
That's perfect. Yeah, and the facilities thing is a great question. It I had a chemistry lab in my house when I was a kid and did a lot of that kind of stuff. But it certainly is a question, and we'll talk a little bit about that. But you can certainly some great chemistry stuff you can do at home. And again, nobody has to speak, but any other questions? I appreciate that, Lily. That's fine. And I'll kind of call on you again in a little bit. Uh, I was real happy to do this with Becca that I ran a program at my last job where we did a science fair within the company for people that worked there. We would have a poster day, very much like a science fair. And we had about 70 different posters, and people would all come together and talk about their work. So I would have the exact same discussion that I'm having tonight with the people I worked with, how to put together a good program. So you'll never be free from science fairs. When you work in industry, every day is science fair to some degree. So a big one is getting ideas for a project, right? So some of you are well on your way. Raise your hands if you think you've got what you want to do versus you're still looking. People that think you've got, Lily thinks she's got what she wants. Okay. And it is tough. I remember my own kids were in school. They're in their 40s now. Neither of them went into science. I don't know why. They're in their 40s now, but working on ideas was one of the big challenges. So one way of looking at this is chemistry is about matter and how it behaves and how it behaves when it's exposed to energy and other matter, how it interacts. Formally in school, they have these different types. My brother is an organic chemist. That means chemistry of carbon. Inorganic means chemistry of everything else. Physical means how chemicals behave, their pressures, their viscosities, their how they flow and behave. Analytical has become a huge field in my lifetime. It's analyzing what these chemistries are. And what I know very little about is biochemistry, which is the chemistry of life, because we are talking and thinking and seeing with chemical reactions here today. So it's a big field. I'll turn around the other way for projects for science fairs, and any of you would happy to chime in on this because I may not have been complete. But some of the obvious ones, the ones I've seen before, for food chemistries, um, ice cream, breads, cooking, spices, that sort of things. These are really good because what you're doing is taking an ordinary substance and ordinary activity. Not all about you. I love to cook. I grew these special beans and I made a bean soup tonight out of this. It's great fun. So I love cooking it. And the cooking of a bean is a fascinating thing because it takes a long time. Well, it was hot quite a while ago. What's going on there? What takes so long for a bean to cook? That could be in itself a good study, right? So how those things work. Food chemistry is really good because, of course, it's safe and you get to eat the results. And we always like that. I did a lot of lab work in my career, and we always said it's a lot like cooking with just a lot more ingredients, but the analysis is not as much fun. You have to stick them in some machine. I made plastics for much of my career. They're fantastic. Do you ever get the chance? And then household chemistry outside of the food area, there's a lot of things, chemicals in your house, the substances in your house, everything from wood to your own tissue. And people have done science fair projects on human tissue and its chemical characteristics, things like soaps, personal care products, that kind of thing, polishes, fuels. There's a lot going on. I mean, just the simple one of polishing a piece of wood, what's happening there? That stuff is filling in the grooves, and then there's impact of light that makes it appear shiny because the refractive index and all these things. There's a lot to it. Another real popular area in science fairs, and one that's just great, is environmental chemistry, having to do with pollution, how pollutants either form in the environment or how they're degraded in the environment. Like ozone is degraded by man-made chemicals, but we need that ozone to protect us from UV. So there's some wonderful pollution-related ones. Then purifying air and water is another great one. Indoor air quality is a big issue because houses are much tighter now, and so getting the pollutants out of the house. So a lot of projects around that. Purifying water, microplastics is a real big one right now. A dear friend of mine that I worked with for many years, this guy has totally gotten into the microplastics, and he makes them himself at home and analyzes for them, and quite a guy. So that's a real hot topic, of course. Things like fertilizers and what happens to them, and then climate change and the whole thing around the chemical effects of climate change. So environmental chemistry is a great area for you. Then there's the classic chemistry, chemical reactions. A goes to B, and I mix these things together and how fast do they go. Things like catalysts, how fast, vary temperature or vary pH or catalyst, something like that. Decomposing hydrogen peroxide is a classic. And then controlling over chemical reactions, making them go the way you want. As one of my mentors taught me, every chemical reaction that can happen does happen. We were making drugs together. And you get all these byproducts. And the way you go about making drugs is you design the whole process in such a way that separating the byproducts from the real stuff is as easy as possible. He taught me how to do that. But controlling chemical reactions is a big issue. You control them by controlling the environment they're in. You have no control over the reaction itself. They do their thing. Another big one is when electricity and chemistry meets. Okay, so batteries is a classic example. Now, experiments in batteries are more tricky because you start getting more hazardous chemicals, but either making your own batteries or studies around lithium ion batteries, which are impossible to make at home because they're air and water sensitive. The metal plating, splitting compounds, a lot of stuff around electrochemistry. It's a big field. I was at Dow for 23 years, as I said, and it's a field of they make chlorine by electrochemistry. That's their main thing. Then colors is an area that I've seen a lot of fun with. There's been like dyeing fabrics and what are colors and how are they made. There's been some great stuff with that. The interaction between colors and fabrics is a really good science fair project because there's a lot to that. It's not just dipping it like I don't know if you made Easter eggs, right? You have this fundamental frustration. No matter how long you leave that in there, it never gets as dark as you hope it would, right? And there are experiments of that type you could do with Easter eggs. So color is very good. Then, as I said before, in biochemistry, it's the chemistry of life. How do organisms do what they do? What chemicals do they use to do this? How do they respond to chemicals? This could be things like fertilizing or other conversions or the chemicals that organisms make in the form of odors and flowers and things like that. So the chemistry of life is really good. Yeah, so I'm trying to give you here is a sense of the span of this, but not tell you what ideas there are. Then polymers or other materials, like this pen here is polypropylene, I'm pretty sure. I used to make that one. I've made a whole lot of polymers in my life. And then there's a lot of other materials, like the metals I'm working on today are a material. And so how are they formed? How are they used? What goes wrong with them? How they recycle? As you know, the whole plastics, microplastics, environmental fate, all that kind of stuff is a real big field right now. So there's a lot to deal with. And these are all ultimately chemistry issues. So polymers and other materials are very good.
This
So
is a really
in
great
general,
list.
please.
John, I was just gonna say this is a really great list, and I think about how you could also think through like because these issues are everywhere of looking
Mhm.
at who do you know in your life that interacts with some of these. Like I know of some artists who use dyes and pottery and how they struggle with that or fabric. And so sort of
Yeah,
thinking through who do you know in your life? Why is it relevant to you and exploring that way. So thank you for this list.
exactly. Yeah, on the one hand, chemistry is kind of a subject that I think most people don't talk about. But everything you touch and see, other than sunlight, is chemicals. So, and of course, we ourselves are one of the most brilliant chemical plants ever devised. So I'd say you can take hot dogs and feed it to kids, and you get bigger kids. Isn't that amazing? Uh, but yes, thank you. In touching it, most people that do science fairs have some people somewhere in their family that has some science background. I know I did. Again, he made hydrogen. My dad made hydrogen bombs. And drawing on your family is a real family and friends and relatives, just great. But the tone of this is that there's 92 natural elements. So every one of them has been touched in some way. So it's a little bit daunting to say, I don't know how I'm going to do this because everything's been thought of before. But what I like to think of it is some kind of twist on another project is just fine. And a lot of the work I do, right, other people know how to make neodymium. We're trying to make a sustainable twist because today's neodymium process makes a chemical called CF. CF4 is a champion ozone killer. It's one of the worst ozone killing chemicals there is. So we're trying to make a way of making neodymium without making CF4. So it's nothing new. People have been making neodymium since the 1860s. But we've got an original twist that we think is going to allow us to go forward with this technology that others wouldn't be able to do. So don't worry if it's a field that people have worked in. Just find a way to do this. Any questions? And I haven't, this is not exhaustive. You'll do some searching and see some others as well. Any questions on this general areas for you? Great. And I hope this is going well for you. Now I'm going to take a little bit of a turn here. A word about AI, the A word. So this is a new development and it's fantastic. So it's going to be with you and valuable to you throughout your entire life. And it's a big deal with the school system and who's going to cheat and this and that. That's somebody else's problem. I'm just here tonight to talk to you about science fairs. I use it every day. So that chemical reaction I was talking about to make neodymium out of neodymium chloride and sodium, they react to make neodymium metal and sodium chloride. But I want to melt the neodymium, and it melts at 1200. Sodium boils at 900. So I get extra sodium in there. Everything's good. I heat it up to melt the neodymium. The sodium boils away. Now the reaction will run in reverse, and sodium chloride will attack neodymium to make neodymium chloride again and sodium metal, which boils off and will consume all the neodymium I've made. So I asked AI, how am I going to resolve this issue? So it's a real issue we have. And I had certain ideas about ways we might do it. And what the AI did for me was it allowed me to test out ideas much more quickly. I say, would that be a good idea? We dig into it while together. No, it's not. But we have one now. I think we're going to be able to do it. It's going to be really simple. So these early days, I mean, it's going to be the story of your life to some degree, and who knows? I mean, and look, I'm not surprised if you use AI for these projects. Again, that's somebody else's problem, how you go about this. But here's how I do it, and this is just the choices. You can use AI to make a so-so project pretty easy. Fine, go ahead if you want. The real thing is, if you use AI and work hard, you can make a project that really might not happen otherwise. And that's what I want to see you do. So think of it as a little bit like a bicycle. It can take you places you can't get to by walking. Yeah, sure, it can make a trip to the store easier, but that's not what we're about. We're in science. We're trying to move into new places. So this is your chance to use these tools to take you somewhere new. Because the objective is to make the very best you have, not just to make it easy. I contend, and I'm a big supporter of AI because, in fact, my generation, we visualized it in the 60s. It was something that's been talked about for a long time. So we were ready for it. And I think this is going to apply to all of your schooling. It's not about making things easy. It's about doing something that you wouldn't have been able to do otherwise, like a bicycle. I was the last class in the college to take their final exam with a slide rule. The next class was able to use a calculator because calculators are new. Oh, calculators are going to ruin us and make us all stupid. You know what the professors did? They just gave us harder problems. I said, okay, if you can calculate so easily, we're going to give you a much bigger problem to solve. And that's what AI is going to do. It's not going to make it any easier. It's still going to be just as hard, but you'll accomplish a lot more. But we expect a lot from you. I look at each of you, and you guys are going to do some great things here. Have fun doing it, okay? Because the sky's the limit. You're at a really good stage. You're just the right age for a new technology comes along. There's gonna be lots of questions, lots of problems, and there will be some bad things happen. But that's AI. Any questions or comments there? And Rebecca, I don't know if you have any feedback on that. I know I probably went off the
No,
script a little bit, but
I did put in the chat, MSF has sent out some new language around what can be used for AI and what shouldn't be. It's not
very good.
counter
Very
to
good.
anything you said, but I think
Right.
it'll clarify some of that
But
as
use
well.
this to be
So,
excellent. And that's what
yeah.
I'm trying to do, right? I want to be the most effective person I can. I'm not trying to do this easily. I love doing this. The last thing I'd want to do is do it instantly. So, and this is the thing for me in the technical field. I think you can see it, hear it in my voice. I love doing this stuff. It's a blast. Working with really smart people. And the great thing about this field is you seldom work by yourself. I don't want a job where you work by yourself. And the other thing that's great about it is not that much screen time. You do a lot more up on your feet, laboratory work, going up and down steps, flying to Malaysia, places like that. These physical sciences are really good that way. So safety and chemistry. First of all, I've been in this business for 49 years. I've never been hurt by a chemical. I've been scared by chemicals. I've had situations where we almost contaminated an entire town with chemicals one time. We didn't. It's a really terrifying experience. I've hurt myself in this business by falling. I've hurt myself by cutting myself, that sort of thing. Probably the most dangerous thing is driving in a car. But we are made out of chemicals and they don't necessarily play well with others. And I don't mean to make light of the things that can go wrong, but the number one thing is the eyes. Okay, there's a lot of just salt water can take your eyes out. So your big thing is eye protection. We'll talk about protection on the next slide. The next biggest thing is lungs, okay, that you don't inhale a mist or a powder or something that can damage your lungs. Again, yeah, it's important, but the fact of the matter is, and don't quote me, but I can put some acid on my skin, and if I wash it off right away, it's no problem. There are chemicals that I've worked with that no matter what you did, they would kill you, no matter how quickly you got them off. That's very rare. Eyes is the big one. And then finally, ingesting, eating this stuff is far less common for the simple reason that we're not allowed to have chemicals in the lab, food in the lab. We'll talk about that. Though there have been examples of the opposite. The artificial sweetener saccharin was discovered by somebody smoking in the lab. They got this stuff on their fingers and they took their cigarette and they tasted the cigarette. So artificial sweetener was discovered that way. But in general, never, nothing ever goes in your mouth in a lab. And this is a knowledge industry. Some people say that chemistry is the first knowledge industry. You've got these two clear liquids and you mix them together and they explode. The only thing to keep you from getting hurt is your knowledge. And chemistry knowledge is very readily available and very easy to understand. So one thing is simple as safety data sheets. You're not going to be able to see this. I'd have to change I'll go back to where I was. But a safety data sheet, and we'll send you this and you can click on the link. Every chemical out there, I have one for Clorox bleach. Every chemical out there has a safety data sheet. So if you're working with a chemical, the first thing you do is search for the safety data sheet for that chemical. It'll tell you what to worry about, what not to worry about. One of the big ones is the LD50. So you can feed rats a lot of Clorox. You don't want to, but you can feed rats a lot more Clorox than you can feed them Tylenol, for example. Tylenol is quite toxic. My brother's point is that you could never get Tylenol registered today. So use safety data sheets. And again, I'm trying to talk to you in practical terms here. The sprays and spills are usually the problem. You dump the stuff in your lap or it sprays and gets in your eyes. There are other things, again, accidental ingestion, explosions are possible, but you can stay well clear of those at the planning stage. So have an eye wash plan and a shower plan. And water is your friend with all these things. You'll always wash it away. And then there's ventilation. We'll talk about that in a little bit. Try to remain standing. Keep the drinks and the foods and the pets away and remain standing. You don't want to dump these things in your lap. It's almost that simple. If you're standing up and they're at arm's length, if they go bad, you can get away from them. And be ready for energy release or gas release. These things may get hot or they may make gas, like you mix baking soda with vinegar and it makes gas. A lot of incidents are around those two. Bhopal was an energy release. That was my old company. We killed thousands in Bhopal with an energy release. And gas releases have been, there was a big incident in Massachusetts with that not too long ago. But it sounds crazy, but with the knowledge and the protective equipment, we can handle any chemical. I don't expect you to do that at home because you don't have the right equipment. But with the proper training and the proper equipment, you can handle any chemical safely. So if you have a question here, and this is a big point, last thing we want is any kind of incident. I know there's a safety form that Rebecca talks about that you'll fill out. But start with her on any questions. We'll find a way to get you the help that you need. This is, again, it's a known field. It's very, very unlikely that you'll do anything that the world has never done before in some way. So we can help you with that. Any questions on safety? So the main thing is be prepared. And these things, the number one is glasses for sure. And I was wearing glasses today when I was working some stuff. Gloves, and usually nitrile is okay, just those thin blue gloves. If you're working with really corrosive stuff, they're not so great. Have a fire extinguisher if you're working with anything that could possibly burn. Basically, just lay all this stuff out ahead of time. Water is almost always your friend. Now, that sodium I'm working with, it detonates when it hits water. That's bad. But almost everything else, if you've got a problem and you put water on it, it's going to get better. You get it in your eyes. So do this. Most of these experiments probably should be done in the kitchen, recognizing that you could contaminate the workspace. You're going to make waste. And it sounds like, well, chemical waste, the worst thing in the world. Well, you're going to be a generator of chemical waste. So you got to figure out what you're going to do with this stuff. And usually it's a matter of putting it in a plastic bag in the trash. If you have any concerns about it, get it wet before you put it in the plastic bag in the trash. And almost anything can go that way, but you got to have a plan. Ventilation where possible. And we're going to be doing this in the wintertime. And so you could do it in the hood on the stove or around an open window if there's any question. But the number one thing with chemicals is that they got their life and I've got mine. And I've had to walk away from these things before. I had a huge 100,000 pounds of stuff do a bad thing one time. And we just went and had a coffee. Let it do its thing. Don't try to mess with it. So ventilation, if it's making bad gases, just get out of the house. And then you have some way of the paper towels emphasize that you need some way of cleaning up your mess, some kind of plan. If you dump it on the floor, what are you going to clean it up with? Usually paper towels are fine, sometimes wet paper towels. Most of the things you work with, things like real strong acids, you don't want to do that, but you're unlikely to work with any chemical that would interact with paper too badly. Then the little cheesy lifeguard here is try not to work by yourself. I never did in my career. I always had somebody with me. First of all, it was a lot more fun. Lab work is kind of slow. You work, you mix the stuff up and you wait an hour, and then you stick it in the machine to analyze and you wait an hour. So you get lots of time to visit and talk about cooking and family and office politics, all that kind of stuff. So make sure you got a buddy with you. Any questions about safety equipment? Sometimes our apron is good, if you're worried about getting it on your clothes. But if you do get it on your clothes or your shoes, throw them away. You can buy more shoes. So safety equipment. So I'm getting towards the end of this. You're having to sit and listen. It's something I just love. And look, this is the nature of this business. It's about teamwork. I've got all kinds of great things I've done in my career. I've done all kinds of stupid things too. But the good and the stupid were always done with somebody else. So don't take on the world by yourself. It's a lot more fun, a lot more safe, and you're going to have a lot more success. I mean, of course, we all do things by ourselves. But if you can get a chance to work with somebody in this, it's going to be just a lot more fun. Again, something I dearly love is the presentation with the team. So, you've got some kind of idea for your project. You're probably not, you can like it for a while and you realize that's not such a good idea. When you get a PhD, you have to choose a PhD project. I went through several of them before I got one I liked. My PhD project was fantastic. Oh, it's great. And I had the most wonderful guy in the world teach me the ropes. His PhD program is a wonderful thing. So learn about the chemistry. And this is where you've got something I didn't have. You have the web. We had wonderful libraries when I came through, but you can learn just essentially anything you need to know about the chemistry that's going on in there. And you'll need that for your report anyhow. And then the planning part. So, you say, what am I actually going to do here? And what I do is I say a day in the life. I say, I walk into this room and it's empty. What am I going to do first? What am I going to do next? So rather than think about the key activity where I mix these two things together, which is the temptation, right? I want to think about this part where I mix them. Think about everything that leads up to it. So just, I say a day in the life. You walk in an empty room, you do all this stuff, and at the end of the day, all the waste is cleaned up, the data's been taken, the chemistry's been done. So lay it out like that. And of course, there's some paper there. Try to keep track of this and take notes because as a judge, I really love seeing this when people talk about how they came to their project and the things they tried to do and gave up on. Those are all just great. So it's really good if you can use these things in your final report too. If you can keep out of trouble, make a better project, and your reports can be a lot better. And setting up the experiments, I think, is a lot like making a meal. And hopefully, some of you cook. If you don't, start. And you have a kitchen, and I like to do this at about 5 o'clock. I go into the kitchen and get everything I'm going to need. I cut up the peppers and I cut the onions and I put them in little bowls. And I get the pan out. I've got it all worked out. And this is thawing, whatever it might be. Then I come in at about 6:30 and actually put it all together. So in our household, we kind of love to do that at 2 steps. And so have that same image in your mind where you got everything all laid out and real good, as opposed to I'm in the middle of it. Oh, I'm going to have to go do this. And so just lay it out like a meal. Now, when you do the experiments, and say you're mixing, here's a typical experiment that people would mix vinegar and baking soda together at different temperatures and measure how quickly it generates gas by how quickly it inflates a balloon, for example. Say that was what you were going to do. So you do some dry runs first because it's the material handling part where a lot of people get in trouble. Just can you pour things from one thing to another? Can you measure small amounts of solids? So we have this great contest at Dow one time where the contest was to simply take an eyedropper and out of a beaker and get 50 cc's of liquid into a graduated cylinder as fast as you could without spilling any. And the technicians that work for a living with chemicals would just go, pop, pop, pop. It was just, perfect. Whereas the engineers like me, that some of them are office jockeys and klutzes, and they just made a glorious mess. So your ability to physically handle, and my family, dad would always pour things like hot grease and stuff because he was so good at handling liquids after being a chemist his whole career. So do some dry runs to make sure you really know how to handle these things. And make sure you got extra starter material because you're gonna mess some of them up. Okay, I mean, I always say that chemical experiments are like pancakes. The first one's never any good. Keep trying and you'll get it right. But if all you did was mix things together in a dark room and then pour out the waste, you wouldn't have anything. So you're going to learn along the way. And observing carefully, one of the things they made us do in freshman chemistry lab is light a candle and write about what we saw. Okay, what is really happening with a candle? Okay, and this is the same thing here. Take a good close look at it. Again, measure everything you conveniently can, things like temperatures and volumes and pressures or whatever they might be. And it's not trivial. A good measurement is not easy to make, and a lot of people have trouble with it. So make a good measurement. You have to write notebooks and report. The thing there is keep it simple. Really, you don't need a whole lot here. Just make sure it's complete. Something that's a lot of fun is the posters and the displays. And you've all been to science fairs, you know these. And that's what really brings in the crowd, a good poster. People love to see the posters, and by all means, put some good time into that. And I have to say, with all this, the science fair projects, I've seen many over the years. Becca gets me a bunch of them to judge. Almost all of them are really good. I mean, the people you're competing against are really good, and you'll make a great poster. So, don't worry about this. You're going to do a great job. But one big thing, and if people fall into this, is look, we're techies, okay? I'm one of them too. We're kind of shy. And a lot of us like to make a fancy poster and not have to say anything. But the poster is supporting you. It's not about the poster, it's about you and your work. So it's great to have a poster, but don't put too many words on it. You don't want people looking at the poster, you want people looking at you. So keep them really simple, really clean. But again, don't get me wrong, all of us techies are introverts, and it's a lifelong problem, okay? And it's difficult for me to talk something like this. And then your presentations, the main thing I want to give to you is again, you and I have a lot in common. think of you, you're talking to your people here. So yeah, sure, we're old and hard of hearing and all that kind of stuff. But the fact of the matter is, we're on the same team here. And I think you'll find a kinship with the judges that you'll find with all other scientists. I was at dinner the other night and I was there with a scientist, fascinating person. Person is teaching classes on artificial intelligence, how it works from a computer science point of view. Everybody else in the room was a non-techie. My wife said, "Could you two just go get a room somewhere and talk about this stuff? Because we just, oh, so great." So, when you find another techie, you're going to love it. And that's what we judges are. We're techies. So we're much more like you than it might seem, given how far apart we are in age. And the presentation is very important. It's a lot of fun because that's what's going to be the big thing in your career is your ability to present yourself. And I like to think I'm pretty good at giving talks, but it came a long time coming. So be sure to really work on that because here's your chance to work on a skill that's going to be really handy for you. So any questions on that? 'Cause I think we are almost done. I have some other stuff that if Becca gives me a chance, I'll talk about. But for now, any comments or questions?
I'm gonna turn off the recording, so let me just do that.